This is Ian, Sloan Fellows video blog, and I'm in another part of the Media Lab right now and checking out some of the more cool open house activities and displays that they're letting people walk around and see. And it's a pretty incredible place. Lots of gadgets and interesting. Sometimes maybe you can't figure out quite what it is when you look at it, but there's people around who will explain what's going on. I'm not sure I'm going to interrupt anybody with my questions right now, but just kind of take a look at the displays and see what some of the stuff that the folks at the MIT Media Lab are working on.
Yeah, it gets like clean and that is active.
So I can
will be able to see that.
Excuse me.
It has the ability to do either or both. And
all right, so there's a robot display going on over here. I want to check that out. Actually, some of these robots, they look familiar. I might have seen them on a TV show or maybe at the MIT Museum before. They're at rest right now.
I've seen them on a TV show before.
Oh, yeah?
Yeah. We've got a little bit of press.
Yeah.
Do you work on both of these?
I'm just starting, but yes, I'm working on some.
So what's the purpose of this particular display?
We started with Nexi.
Okay.
And Nexi's main purpose is, correct me if I'm wrong.
Oh, it's Jeff.
Her main purpose is to interact with people.
Okay.
And so it's mobile, dexterous, and social. So we started this lab started with Leo here. And
Leo is that fuzzy gremlin-looking thing?
Those are better. Those look like but Leo started off as kind of a social creature that was really meant to explore human-robot interaction.
Okay.
And I think we had the lab had Leo for quite a number of years, and we wanted to move to something a little bit more mobile.
Okay.
And so we got a mobile base, and we worked with a couple of labs. We worked with University of Massachusetts, and we got their U-Bot base, which is this looks like kind of a Segway base in the arms.
Okay.
And
can I get a little bit closer to it, or
sure.
I want to make sure don't.
Yeah. And this is Matt, by the way, and this is Nexi.
Okay.
We're moving more into a multi-robot thing too. So
What does multi-robot mean?
well, in this case, we're interested in kind of the group dynamics.
Okay.
So in this case, we're looking at how Nexi can actually interact with large groups, not just single people, but large groups.
Okay.
Now. And we wanted to also use another robot to add to that group and to have communication between robots and humans.
Okay.
And I don't think there's been a lot of studies where you have robot-human.
Right.
Where communication between the robots is actually important for the human in understanding how robots can communicate in a way that humans can understand and interpret those kind of
Right, so picking up the dynamics between these two robots
Yeah.
interacting, and then humans can figure out what's going on. So it's not just like a silent connection. There's something else going on that people can figure out?
Exactly.
Okay.
Yeah. And also just kind of exploring all kinds of, psychological dynamics. So, we like to stay certain distances away from robots. This would be very awkward, if I were interacting with a robot this closely.
Okay.
But for a robot, that's perfectly fine. So,
Okay.
So really, it's about creating behaviors that are natural for humans. And also, between two robots and a human, what's natural between all of those.
Right.
So we just brought up Maddox last night.
Okay.
Though there's a few issues. We don't want to really show it until it's just right.
So can you explain the hardware a little bit about how this works?
Yeah. So in this case, we have again the U-Bot kind of design starting off. We have a base here for a Hakuyo. There's a Hakuyo sensor over there.
So it's a video sensor that will see if something's in front of it?
Yeah,
Is
it's
that
like
the
a
idea?
rangefinder. So
Okay.
it gives you kind of a one-dimensional, just sort of a two-dimensional plane across a field.
Okay.
So you get kind of like legs and like chairs and things.
Right.
And it's used for mapping. And then this is also the Segway base. So this can, it has the ability to balance, but this costs so much, we're not really willing to risk the cost of it falling down even once. So
Right.
we don't actually use the Segway base.
So this is a real Segway base that because you used the term you robot or something before?
So there's, I mean, I'm calling it a Segway base, but
Right.
it's not actually Segway.
Okay, it's another product that's similar to that.
It's a research tool, yeah. So it was built by University of Massachusetts at Amherst.
Okay.
And they are studying kind of the dynamic. So one of the nice things about this is that you have this whole dynamic base here,
Right.
where you have the inertias are constantly changing, and they have a demonstration of their robot throwing a ball.
Okay.
And it's really amazing. It looks really natural, and it's just kind of on a base, and it's got these arms, and it's a really complex dynamics problem.
Right.
We were working with them, so they provided us with a base.
Okay.
We kind of took those designs and changed them a little bit for this one. This was their original base.
Right. This is the Generation 1.
This is the Gen 1. This is the Gen 2.
I mean, they look similar in many respects. This one's shorter though, has a slightly different color on the head, and there must be some other major differences going on too.
Yeah. So I think it's actually lighter. This robot.
Okay.
So it can kind of balance a lot easier than this one.
Right.
There's if you imagine kind of an inverted pendulum.
Okay.
There's a really heavy top to this one, whereas in this one it's a little bit lighter on the top. The other one here, we have some Mecha arms. It's a company, MEKA, Mecha
Okay.
Robotics, and we've been using their arms, but we wanted a little bit extra feedback, so we started to use these Zytome arms.
Okay.
And when we did that, we found that the arms were quite a bit taller. I don't know if you can tell.
Yeah.
And so we had to increase the base.
Oh, I see. So that's why it's taller. This one is taller than that one, mainly because of the arms.
Right. And so this one is going to have significantly better manipulation abilities.
Okay.
And Nexi will.
Now, I also see, and I've seen this before on the Kismet, I think was the name of the robot. It could move its eyebrows and things like that. That's to show expressiveness and.
Right, and it's what we've really found is that's extremely important for human interaction.
Okay.
Humans like to really associate with other creatures that can express emotion.
Okay. And that's through facial gestures. So besides the eyebrows, what else would happen if this robot was reacting to a human being?
So you can also couple the facial expressions with actual hand gestures. So the robot can give you an excited face and tell you that it's happy, but it can also give you a thumbs up. So coupling those two expressive capabilities really brings out, it really makes people, there's a sense of this is a human.
Right.
It's almost a human creature, and it makes people want to be engaged with it a lot more.
Rather than being like the stiff, stereotypical
Exactly,
robot.
It's not just a statue, it's actually moving things, and it's becoming a little more fluid in its actions, and it's more believable to people.
Right, that's really cool. So, and one last thing, I mean, it's a kind of a kid-sized robot. Is that by accident, or is that just relating to the size of the base and how well it rocks back and forth?
So that's really intentional by design.
Okay.
So one of the things is that we want to get away from the intimidating robot syndrome that so many people fear. So we want to keep the robot sort of at a size where it's not as intimidating for people. Right. So if it were as tall as you or as tall as I, little kids may be frightened by that. So we want to try to keep it, at a certain height so people aren't as intimidated by it.
Have you been testing it with children at all, or is it mostly people that work here in the lab?
So we've done a few experiments, but all of the experiments have been done with adults.
Okay.
We had some children come here and sort of check out the robot, see its functionality. What we find is that children are either terrified of it or they love it. So we try to find a healthy balance, and how we do that is again by design. So you can see the face is very, very human-like, but the rest of the body is all exposed, you see wires, computers. That's so that people, particularly children, understand that yes, it's almost a human thing, but it's also a machine. Okay. And it's clear to them that they know it's just a machine.
When you say that kids are terrified, is it usually age, or can it be just a random thing?
It's a random thing.
Okay.
It's very random.
Okay. Well, thanks so much for taking the time to explain it. I hope I can see them in action sometime.
Yeah, definitely. And also, so we have these two new robots here that don't have names yet. So we have this little Name That Robot competition. You should definitely submit your vote for that.
Okay. Yeah. Well, thank you very much.
No problem.
Thanks a lot for taking the time. Bye-bye. How cool is that? All right, Name That Robot. As I'm in the middle of